Hi, and welcome to SPSS for Psychologists. Today we're going to talk about some basic statistical concepts. So, what is SPSS? Do I need to know anything before I use it? Well, yes you do, but don't worry about it because I'm going to tell you everything. So, data, variables, and cases. So whatever you do, whatever experiments you do, whatever you conduct whilst you're being in your little psychologist circles, don't worry about this, you will use either qualitative data or quantitative data. Qualitative data is something that you can describe by words. So for example, subject 37 turned green. Or qualitative data, which is something that you will measure, which is a number. So all of your like heights, weights, shoe sizes, sex. Yes, you heard it here, folks. Sex is apparently a qualitative data. I don't know how you can measure this. Don't ask me how this works. So each of these things, each of these data, well, whatever you do, you're just going to have loads and loads and loads and loads of variables. Now, what is a variable? Well, a variable is just something that you measure. So for example, if you have 10 kids, shoe size of these kids will be a variable. Why? Because it's a quantity that changes from each kid to the other kid. I mean, variables, it's year 7 science. I think you can do this. So then, variables come from cases. So going back to the 10 kids analogy, if the shoe size of the kids is the variable, then the kids are the cases, because cases are the things that you take the variables from. So you have a case, you ask it for the variables, you have the variables, they come from cases. Simple. So, levels of measurement. There are 4 levels of measurement or types of scales. There's the nominal, ordinal, interval, and ratio. You thought there were 4 different types of scales: nominal, ordinal, interval, and ratio. Well, do not be misled, because there are actually 3. Why are there 3? Well, it's because SPSS was sick with y'all bullshit. All these scientists coming in and being like, well, I have to use either interval or ratio, but I don't know which one to use. Which one do I use, interval and ratio? And then one person saying, oh, you have to use interval, and the other one saying, oh, you have to use ratio. And then SPSS was like, do you know what? No. I don't care. I don't care about you or which one to use. I'm just going to solve this by merging them into one. This one is called scale. So, when you use SPSS, there are only 3 types of scale: nominal, ordinal, and scale. But what are they? I don't know. Nominal, ordinal? I mean, there was 4, now there's 3. This is all confusing enough. Don't worry, chill. I'm gonna explain everything. So, the nominal variables are the nominal, name, you see the relationship? Yeah, the nominal in the name, yeah, that makes sense. Basically, it's when you use number as a name. So let's say that in your questionnaire, you have male and female. You label female as 1 and male as 2, or the other way around. It doesn't really matter, because what you're doing is you're not saying male is more than female. You're just giving it a name. So then when you use that statistic, you can say there were 155 1s and 252s, so there's more males than females. So you're not saying 2 is more than 1, it's just like giving it a name. So female is called 1. Your name is 1. Ordinal variables is when you want to order something. So let's say that you have 10 people and they all scored a number in the test that you've given them. Using the ordinal variables, you would basically order them. So this person did the best, so they rank 1. This person did second best, so they rank 2, etc., etc. However, they're not really that useful because, well, you can tell who did the best, but you can't even tell the difference. It's not going to tell you, oh, the difference between these was that much. They're just going to tell you this one did best and this one did not best. So don't use them on their own, because on their own they're pretty useless. So now we're going to be talking about the magic 2, but actually just 1. Scale variables. So this one is used for, when you do these really annoying questionnaires when you're just like, oh, I strongly agree, I slightly agree, I don't have a comment, slightly disagree, I strongly disagree. These. Yes, so this is what you would use for this. You would set a certain value to each answer. So for example, strongly disagree is 1, but strongly agree is 6. And you would be like, okay, so strongly agree is more than strongly disagree, so that you can then put this data into use when you calculate what comes out as a score of the test. So the only difference between the intervals and ratio is that one of them counts 0 and one of them doesn't. And when people were like, for example, think about attitude, and we're like, well, is 0 an attitude? Can you have an attitude of 0? And one person was like, yes, you can definitely have an attitude of 0. And another person was like, well, but you never actually have an attitude of 0. And SPSS was just like, no, I'm sick of this. I cannot work like this. This is too much pressure. We're just going to blend them. We're going to use scale. So scale is basically just kind of a mix of these two. I mean, only SPSS know how this actually works. Related and unrelated design. So when you use SPSS, it's important that you know if your design is related or unrelated. So the actual difference between the two is related design is when you take more than one variable from one case. So let's say you have your 100 cases that you take variables from. If from each person you take the age and their reading speed, then that is a related design because you took 2 variables from one case. Unrelated design is, for example, if you had males and females, which in this case you don't measure. I know I get confused with this as well. And when you have males and females and you compare their strength, that is unrelated because you only take 1 variable from each person. Don't get confused, because then when you have 100 cases and you compare the difference of each person, that will be unrelated design. So there's technically unrelated design within related design, but if that's too complicated, just focus on this very primary thing. So there are 2 types of statistical analysis. One of them is descriptive statistics. So these are the things that you can name. So for example, this is the average pay of a manual worker, or this is the average amount of money people spend on energy, something you can name. Or it can be even a range. You ever seen one of these? Yep, that is a range, and you can use that as well. That is still a descriptive statistic. However, there is another type of statistics, which is an inferential statistic. Now, these are very much linked to the descriptive statistics. Like everything in SPSS, it links. We're all in this together. Sorry, I got a little bit off track. So inferential statistics are, well, they don't only name. So the descriptive statistics only name what something is. The inferential statistics kind of ask questions. So let's say we have 2 descriptive statistics, and we say, right, this is the amount of money an average person gets per year, and this is the amount of energy, the money an average person pays for energy that they use up in their house. Now we can take these 2 and be like, is there a correlation between these 2? So inferential statistics, at the end of the day, is just like an analysis of the descriptive statistics, if that makes sense. I hope it does. Now, with each research comes hypothesis, because hypothesis is that thing that you make the research about, and a null hypothesis. Now, what are these? Well, a hypothesis is you basically saying, this has an effect on this. You're basically, you guys are so full of yourselves, like you are sure you are right. You're just like, yep, this is happening. Well, anyway, a null hypothesis is basically you saying, no, there is no correlation. Technically, what you should be trying to do in your experiments is disapprove the null hypothesis. So you can be like, yeah, you see how I disapprove that there is no correlation? That means there's some correlation, so that technically means my hypothesis can be right. But everyone ignores that. They never put it in any of their research. They just kind of ignore the null hypothesis and they assume that their hypothesis is right. Which, yeah, you guys are just basically snobs. However, these hypotheses, they divide into 2 types. There's the one-tailed hypothesis and there's the two-tailed hypothesis. So that kind of makes sense. So imagine that you have 2 things to measure, right? Is there a difference or is there not a difference between 2 things? And which one is bigger? So one-tailed hypothesis is you saying, okay, there's going to be a difference and number 1 is going to be bigger than number 2, because you are so sure of yourself that you will just make that jump. You will just going to kind of think, right, I'm going to disregard the chance that this is not true, and I'm just going to, go for it. That's fine. Many people do that. So if you imagined it as dots, right? So here is a dot. It can happen. It cannot happen. Like, there is a difference. There is no difference. And then it says it's going to be bigger. Number 1's going to be bigger. Number 1 is going to be smaller. So if you think about it, you would draw one line. So there is a difference, and it's going to be small. It's going to be bigger. A two-tailed hypothesis is when you are not so sure of yourself. So you kind of think, right, there is going to be a difference. However, number 1 might be bigger, number 2 might be bigger. So just in case, I'm going to draw 2 lines. And do you know what? SPSS loves you, but we're going to talk about that later on. So, the clue to a lot of this is understanding inferential statistics. So first, populations and samples. What is a population? What is a sample? Well, I'll tell you. Let's say that you are making a research about donuts. Your population would be all the donuts that have ever been made in the world. So if you were to make a research about the whole population, you would basically go and have to eat every single donut in the world. Not a very reliable method, is it? Pretty much impossible, which is why we have samples. Samples is when you take a little, really, really small bit of that population and you just really, really hope that this little sample will be somehow representative of the whole population, which I personally think is ridiculous. But as we've already said, you've made so many jumps and conclusions without any, kind of indication that, you might as well. Why not? So, linking to this are parameters and statistics. So a statistic is when you take all the data you have out of your little sample or population, and when you take a mean out of this. So you add them all together, divide by the number. You've ever done mean before? Yes. So that's what you do, and that's a statistic. A parameter is if you had the whole population, if you somehow managed to get the values for all of the population, and you took a mean of that. So that is a parameter. However, because we know that getting the values of all of the population is pretty much impossible, we can never get the parameter. However, what we can do is, how before you've kind of assumed that this little sample is representative of the whole population? Well, you take the mean and you just kind of assume, you just kind of make the guess that maybe this is what the parameter would look like. Psychology is all about guesses. How is that even a science? So, after all the wild guesses you've took, we are coming to a magic letter, P. This is about inferential statistics and probability. So, as I've said before many times, because it still disturbs me inside, psychology and all of its experiments is really a lot about just taking a guess and just assuming what you're thinking is right. So, the magic letter P is the probability that what you are talking about is basically just by chance. So you've got all your values and you just kind of like, ooh, so people from Britain are much stronger than people from Australia, because I've measured the strength of 1,000 people from Britain and 1,000 people from Australia, and the mean is much bigger in Britain. And then the value P will just be like, yeah, that's bullshit. Basically what it does, it's a value between 0 and 1, so it's basically a percentage, and it says how many percent of a chance, of a probability that all the work you've done was basically a chance. Now, scientists and psychologists really, really don't like to not know. For the amount of wild guesses you make, it's incredible how much you don't like to not know. So what they do, they've all met up one day, and they said, okay, so because the value P is never 0 and never 1, because why? Because you can never be sure that it's a 0. You can never be sure that it definitely doesn't link at all. Or you can never be sure that it's 1, because everything is possible. So it is never going to be 0. So they all just met up and they said, well, 0.05 is pretty close to 0, so if you ever get 0.05, how about we just assume it's a 0 and we're gonna go that yes, this is definitely a statistically significant result. That's what happens. So now if you ever do your research and you get a value p, which is smaller than 0.05, you done it, gal. Now, as I've said before, to the people who like to use the two-tailed hypothesis, SPSS really likes you because you don't take as many wild guesses when you assume that both possibilities are right. The p-value is going to be more, it's going to be a little bit more reliable if you use the two-tailed hypothesis. However, if you do use one-tailed hypothesis, and that's totally fine, what you can do is you can use thingy-majiggy with the maths and the computers, and you can make a p number that's actually for one-tailed hypothesis. Or the easier way is to just take whatever you get for two-tailed hypothesis and divide it by 2. I don't know how it works, but 2 divided by 2 is 1, right? So that is going to be this for today. I hope I've helped you to understand at least a little bit of what SPSS wants and what you need to know. I will come back to you with a second episode that will explain a little bit further what this is all about. But yeah, this is it, and I hope I've helped you, and I will see you in the next episode.